Hello, everyone. This is Juan, a research fellow from the University of Adelaide. I'm here to present our work for MICCAI2023 called Learnable Cross-modal knowledge distillation for multimodal learning with MICCAI modality. As we know that nowadays, the data usually contains multimodalities, for example, like automatic driving or medical image processing. But sometimes the modalities will be missing from the multimodal data. This is critical for the performance of model. If the model didn't design it specifically for missing modality issues, the performance will drop dramatically. So here, our paper is to tackle this issue. There is an important fact that usually for a certain task, there is one or several modalities contribute more or outperform other modalities. And this has been overlooked by other models. But we keep this in mind and design our LCKD model to address the aforementioned missing modality problem in multimodal learning. It is a simple and effective model from the viewpoint of distill cross-modal knowledge to maximize the model performance. More specifically speaking, the LCKD model automatically identified important modalities and distill knowledge from those top-performing modalities into other ones. And we conduct experiments on BRAS 2018 and demonstrate our idea, and our model can outperform other models by a large margin. Here's the structure of the proposed LCKD model. If we have capital N modalities, one or more modalities are missing, we would designate the top performing modalities as teachers per task. For example, BRAS has 3 types of tumors, then we have 3 tasks. Then through a teacher election procedure, we will select the best teachers for each task. And the knowledge will be distilled in a feature level. And we also generate missing modalities here for decoding. So let's have a look at the individual steps. Firstly, teacher election procedure is a validation process that is applied to select the best teachers. And we also have the process to get rid of those duplicated ones. For cross-modal knowledge distillation and missing modality feature generation, we would approximate all available modality features to the available teacher modalities in pairwise manner through a KD process. And for missing modality feature generation, so the feature space ought to be close to the genuine features that uniformly perform well for different tasks. For training and testing of LCKD, we have this alpha as trade-off factor to balance these 2 losses. So let's look at the experiments now on BRAS 2018. This dataset contains 3 types of labels can be formulated to 3 types of tumors, enhancing tumor, tumor core, and whole tumor. For ET, the best performing modality is T1C, the same for TC, but for WT, the best one is flyer modality. So this dataset contains 285 cases for training and validation, 66 cases for testing. So looking at the table, our LCKD model can consistently work better than the others on different combinations of missing modalities, especially under the ones without the best modality. For example, like the first row for ET and the second row for WT. We also examine different variants of our LCKD model. For this is single teacher versus multi-teacher. So as we mentioned before, 3 types of tumors has corresponding the best teachers, T1C, and flare. So for a single teacher, because the T1C appeared twice for 2 types of tumors, while the flare only appeared once. So then we will select T1C uniformly for 3 types of tumors as LCKDS. But for LCKDM, we will select multiple teachers as T1C and flare. Both of them will be teachers. From table, we can see LCKDM and LCKDS perform very similar for ET and TC, because the T1C would be selected as teachers anyway. But for WT, the situation will be different. LCKDM perform better than LCKDS because in the multi-teacher setting, the flyer will be teacher, but the other one will not. So this shows the superior performance of LCKDM. So here's the visualizations. For more results, please refer to our paper. Thank you.